Hello, welcome back. Today let's try to solve another Leetcode problem. 1761, minimum degree of a connected trio in a graph. So this trio means a triangle which are connected. So the trio just means a triangle. So we just need to return the minimum degree of a connected trio in a graph, or -1 if the graph has no connected trios. Yeah, so in this example, 1, 2, 3, so it is a connected trio. And we need to return the minimum degree of a connected trio. So the minimum degree is 3 because 1 and 4, 2 and 5, 3 and 6, they are connected. So the minimum is 3. Because here it is said the degree of a connected trio is the number of edges where one edge point is in the trio and the other is not. For example, this 2 and 5, 2 is inside the triangle and 5 is not. So it is it is a degree. So we're gonna plus 1. And here for this 3 and 6, 3 is inside the trio, 6 is not. And this 4 is outside the trio, 1 is inside the trio. So in total, there are 3 degrees. So we're gonna just return a 3. And for this example, let's try to check this 1, 4, and 3. So this is a trio, but there's no other ends outside the trio, so it's gonna be 0. So 0 is the minimum. We're gonna return a 0. If we cannot find the triangles like this, we just need to return a -1. Yeah, because we need to return -1 if the graph has no connected trios. So for this problem, we need to check the values of the n. N means how many vertices. So the vertices is 400. Yeah, can we try to solve it in n cubic? It means 400 times 400 times 400. It is less than 10 to the power of 8. Yeah, we just need to check if it can pass. Normally for Leetcode, it can pass. Otherwise, we may try to use other method. Yeah, so 400 to the power of 3 equals to 6.4 times 10 to the power of 7. Yeah, so it is less than 10 to the power of 8. It means normally this can pass for the brute force. So for brute force, we're gonna prepare a adjacency matrix. So for the adjacency matrix, inside the adjacency matrix, so if G is a graph, if Gij equals to 1, it means it is connected. Yeah. Let me initialize the adjacency matrix first. So from the beginning, it's gonna be 0 times n for I in range n. So inside the adjacency matrix, so let me prepare an example. So if it is like 1 or 1, 1, 0, and let's prepare another one, maybe 0, 1. So this means inside the matrix, this is 1 and 1 means it is vertices 0 connected with itself. This is vertex 1 connected with itself. It means it is not connected. Yeah. So if this is 1, as you can see, this is 1. It means vertex 0 connected with vertex 1. So for the vertex 1 also connected with vertex 0. So this is the meaning of the adjacency matrix. So inside the matrix, if it is 1, it means for I and J, they are connected. Yeah. If we can find 3 points always be 1 inside the adjacency matrix, so we can get the conclusion that these 3 points can become a trio. Yeah. So for example, if I prepare, just an example, prepare more points. If 1, 2, 3, they are connected. Yeah. So here gonna be 1. Yeah. And inside here gonna be 1, and here gonna be 1. So if we can find 3 vertices inside the adjacency matrix always be 1, it means these 3 vertices are connected. So it means we find a trio. What we need to return, we just need to return the maximum, the sum of the degrees. For example, the sum of this one, the degree of this one is 3. For number 2, for the vertex 2, it is 3. For vertex 3, it is also 3. So the sum of them is 9. 9 need to minus the 6. Because for a trio, for itself, it's gonna be 6, because 2 and 3, 3 and 2, 1 and 2, 2 and 1, 1, 2, 3, 3, 2, 1. Yeah, because the graph is undirected, when we are preparing for the graph, we will prepare 2 edges, 2 to 3 and 3 to 2. So this is why we can get the result by the brute force. Now let me prepare. But we need also to prepare a degree. So the degree is an array. Degree is an array. Inside it will be 0 times n. Now we are going to check one by one, accumulate all those degrees. If we are giving edges, so we can use the edges to get the result of the adjacency matrix and the degrees for each of the vertices. Yeah. Now we can just loop through the edges for UV in edges. Now, because our vertices are starting from 1, but easy for calculation, to make it easier, we can use u minus 1 and v minus 1, because the vertices here always more than and equal to 1. It started from 1. So basically for our calculation, for the degrees, we're going to start from 0. And also for the graph, basically we're going to start from 0 for our calculation, because that is easier. So u and v should equal to u minus 1 and v minus 1. So we are starting from 0. Now, we just need to check our vertex, put the connected edges into the adjacency matrix and degrees. Yeah. So for the adjacency matrix, let me put it. Yeah, let me delete these areas to make it easy for coding. So for the adjacency matrix, so for the GUV should equal to GVU, and it should equal to 1 because they are connected. The edges always be connected. Now we just need to put it inside the degrees. For the degree, u should plus equal 1, and degree v should also plus equal to 1. Yeah, so for this one, we prepared the adjacency matrix and the degrees for each of the vertices. After that, we just need to use the brute force to get the result. Because we need to calculate the minimum value, so for the result, I will define infinite. Because after that, I will check the minimum value. We can just use brute force to loop through all of them for I in range n. N is the number of vertices, so for j in range I plus 1 to n. Yeah, so for here, for this j, it will not start from 0. Otherwise, there's a lot of duplicate, because for 1, 2, 1, 3, 4, we just need to calculate once, 1, 3, 4. We don't need to calculate 1, 3, 4, 3, 1, 4, 4, 1, 3. So in total, there are 6. So it means if, yeah, from my previous calculation, yeah, if 6.4 times 10 to the power of 7 and times 6, it's gonna be time limit exceeded. Later on, we're gonna try to check if it is a time limit exceeded when we are not using the I plus 1 or not. Yeah. Now let's just prepare the code for the next vertices. So for k in range j plus 1 to n. Now we can just check. So the condition is if j, I, j, and g, I, k, it means I and k are connected, and and z. This means IZ connected, IK connected, so the ZK should also be connected. So the Z and K connected. Yeah, if they are always be equal to 1, it means it becomes a triangle, it becomes a trio. Now, we can just get the result. The result should be the minimum because we need to calculate the minimum of the result with. So if it always be 1, it means this the sum of them will be at least 6. So we need to use the sum of them. It is the degree I plus degree Z and plus degree K. Yeah, let me make it longer. Yeah, and here need to minus a 6 because this number is more than or equal to 6, so it will be more than or equal to 0 if we have the result. Otherwise, the result will be the infinite. So we can just return result if result not equal to inf. If the result equal to inf, we're gonna return a minus 1. It means we didn't find, because here said if we didn't find, we're gonna return a minus 1. Now let me run it to check if it works. So yeah, else here we need else minus 1. Yeah, we return if a result not equal to infinite. Otherwise, we're gonna return minus 1. Let me print out the degrees for check if there's something wrong. Yeah, so for the degree, it is 3, 3, 3, and to this graph, it is right, and for other point, it is 4, 5, and 6, it is 1, 1, 1. It means it is right, but our result is not right. Let me check the result. Yeah, let me print out the degree just to check if the degree inside is right or not. I think I don't need to check the code anymore. Basically, it's just brute force. Yeah, a lot of 311. Yeah, it means we got a 311. It is not right. We should not print out the 1. So here is the check. Yeah, here there's a typo. So this is ZUV, and here should be ZVU. Yeah, if there's a typo, definitely I will get a wrong result. Now let's check. Yeah, now it seems okay. Yeah, but before submitting, let me delete the print. Otherwise, it's gonna influence the speed and memory. Yeah, now let me submit it to check if it works. Yeah, and by the way, the time complexity is n cubic. Yeah, because this is just brute force. As you can see, it works. and it is like 3 seconds. Now I'm going to try, to use the IC key starting from the 0 point. Just have a double check if it works or time limited. Yeah. Now let me just run again to check if it works. Yeah, if we times this 6, it means it will be time limited. Yeah, for Leetcode, I don't believe it can pass for 10 to the power of 8. No, yes, now let's just try to check if it is time limited or not. Yeah, as you can see, it might be time limit exceeded. Yeah, because normally if it times 6, it's gonna be it's gonna be 10 to the power of 8. If it is to the scale of 10 to the power of 8, at least for Leetcode, it cannot pass. If it is less than that, it's gonna pass. I think this is also designed, for the Leetcode to let you to avoid the duplicate. Even you use a brute force, you need to avoid the duplicate of each point. Now let me submit it again to check if it works. Yeah, as you can see, it works. Just the same time, 3 seconds. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.